doing a projectile motion. So it's part of mechanics, and there's 2 dimension, which means that we have the vertical and horizontal component with an angle. So that's the projectile motion. And we have a volleyball player that slams the ball overhead and towards the opposite side. The angle of the spike is difficult, as you know it, and the height is 2.30 meter, speed 20 meter per second, downward angle that's 18 degrees. How much further the opposite flow will have if the angle is changed to 8 degrees. So that means we have an equation which is our initial height, which is y0, that's 2.3 meter, and our final height, that's 0 as it moves from the top to the bottom. Initial speed, that's 20 meters per second. So initial speed, that's going to be negative. Why? Because it's going down. We take all the components that's down as negative, so that means down is going to be negative. And now we have the equation for down as negative as initial position minus final position minus initial position is equals to the initial speed multiplied by sine of the launch angle times time minus a half g time squared. And from there we have final 0 minus 2.30 meter, and that is going to be initial speed of 20.0 meter per second negative. And then the angle is 18 degrees angle, so it's 18 degrees. 18 degrees, and then multiplied by time minus a half, which is 9.8 meter per second squared. All that multiplied by time, is gonna be time squared. So that's gonna be time squared. That's gonna be time squared. And then we have to simplify. That's going to be negative 2.3 meter, and then we take that part, we simplify that part, which is going to be minus 20 multiplied by sine 18, giving negative 6.18, and then multiplied by time minus a half, that would be half of 9.8 is 4.9 multiplied by time squared. So we need to know the time that the ball will reach the ground. So 4.9 t squared plus 6.8 t. So we're changing positions, and there's minus 2.30 is equals to 0. So we have to, that is the landing time. So what time is it going to land on the ground? And then we use quadratic equation, and then our A is 4.9, our B is 6.18, and our C is negative 2.30. And then we have T is going to be negative B plus or minus the square root of B squared minus 4AC all over 2A. So that gives us negative 6.18 plus or minus square root of 6.18 squared minus 4. Our A is 4.9 and our C is negative 2.30. All that over 2, and our A is 4.9. So that's the value of our time. So time is going to be we're going to 6.18 squared minus 4 multiplied by 4.9 multiplied by negative 2.3, squaring that minus 6.18. That's going to divide by 9.8, because 2 times 4.9, 4.9 is 9,8. So answer is 0,30 second. So as 0,30 seconds, so that's actually half of a second. And horizontal distance, so now that we know the time it takes to land the ground, so we need to know the horizontal distance that it has covered, because when it lands on the ground, that's the final position, the time it takes to the final. So it's initial times cos theta multiplied by time. Our initial is 2.0 meter per second, and then multiply that by cos 18 degrees. So that's cos 18 degrees multiplied by our time is 0,30. So 0,30 second. The second cancels out and we're left with meter. So 2 times cos 18 times 0,30 is 5.71. So it's going to be 5.71 meter. So that's the horizontal distance covered when the angle is 18 degrees. So we need to know now when the angle is we need to know changing angle. So now changing angle to 8 degrees, how much time is it going to take to reach the ground at that angle? So initial minus final minus initial displacement is equals to initial speed times sine of the launch angle multiplied by time t. So time t will be second time at the angle is 8 degrees is equals to half times gravitational force times time squared. So that's 0 minus again 2,30 meter is going to be initial speed. It doesn't change, it's the same speed, negative 20,0 meter per second. And our time is our sine is 8 sine of 8 degrees multiplied by t2. So that's t2 minus a half gravitational acceleration times t2 squared. So that's gonna be t2 squared, and that's going to be negative 2.0 that there, giving us 20 times sine 8 times 20 is going to 2,78. so it's negative 2,78 35 times t minus that's going to be half of 9,8 is going to be 4.9. so 4.9 again, that's going to be t2 squared. So we need to know the other time it will take if the angle is 8 degrees. So simplifying that's going to be 4.9 t squared. So taking everything from right to left, the sign changes. So it's going to be positive 2,7835 t2, okay, minus 2,30 is equals to 0. And then once again we're going to use quadratic equation. So t2 is going to be negative b plus minus square root of b squared minus 4ac, all that divided by 2a. And then we know that our negative b is going to be negative 2,7835 plus minus square root of 2,7835 squared minus 4. Our a is 4.9 and our c is negative 2.30. so remember that over 2a, a is 4.9. so our a is going to be 4.9, b is going to be 2,7835, our c is negative 2.30. So that's going to be so t2 is going to be that one there is positive, and then that has to be squared, 2,78 squared 7835 squared minus 4 times 4.9. Okay, 2,7835 squared minus 4,4.9 times negative 2,30 gives us root that minus 2,7835 divided by 9,8 gives us 0.4576. So 0.46 when you round off, so 0.46 seconds. So that's the second time when the angle is 8 degrees. So let's see the horizontal distance covered at that time at 0.46 seconds. 0.46 seconds. That's going to be initial speed multiplied by cos of an angle, a launch angle, multiplied by t2. So that's 20 multiplied by 20 meters per second multiplied by cos 8 degrees, and then multiply by 0.46 seconds. And once again, 20 times cos 8 times 0.46 is 9,11. So it's going to cover 9,11 meter. So 9,11 meter, because it took longer, the time is 0,465. And then ball travels 9,11 meter minus 5.71 minus 5.71, and that gives us 3,40 meter. So that's the difference, and that's our final answer. Our final answer is 3.40 meter. Thank you so much for watching. If you do have other problems similar to this, don't hesitate to send forward, and don't forget to follow or subscribe. Yeah, that'd be much appreciated. Thank you so much. Any question, please don't hesitate to leave below on a comment.